Thank you. Thank you, Ingmar. So I don't need to talk about myself. He has given enough introduction. Beyond AI hype, building machine learning systems that serve communities. So welcome everyone, and I'm so happy to be here today. Yeah, I'm wearing two hats, so from Lisan and Dare. So there are kind of like three keywords here: AI hype, building machine learning systems, and communities. So broadly in this talk, when I talk about communities, I'm talking about speakers of languages, those mainly spoken in the Horn of Africa and broadly in the world. So let's start with some reality check of current technologies, with the most advanced ones, let's say, that everybody's working on, large language models or chatbots. And this is a question, a prompt I was given at the Global Media Forum in 2024 in Bonn. And there was a panel, and the discussion was, what are the biggest challenges for media systems in the global south in the context of disinformation and AI? And the panelists put this prompt to ChatGPT, and she said, like, okay, my job is done. The English output is just so perfect. I couldn't have added anything. You know, let's just grab coffee and go. She added, oh, but let me try it in German. And since she's an expert in this area, and she's a German native, she was like, oh, I could have done a little better in the German version. And the question was for me, hey, Asmi, could you please translate this into your language and tell us what you find out? And so these are some of the results I'll show you, outputs of GPT-4 for Amharic in this one. And, you know, I don't need to read all of this, but to make it easy for us, I have color-coded the outputs in terms of things we can understand, we can all see. So in purple are words that make sense, and then in green are words and fragments that were copied from the prompt. And then in blue, I circled stuff, put stuff around, you know, out of context words, and in red are completely gibberish or broken, made-up words that don't exist in the language. So overall, unfortunately, unlike the panelists, I'm not happy about the result, and in fact, it doesn't, you know, answer the question at all. So the output is kind of gibberish. And another one for Tigrinya, my native language. So same process, translated the prompt and gave it to ChatGPT. So there is some structure again. If we used the same sort of like color coding scheme, you'd see more red, like more even made-up words in this language, and more out of context words, and in general, here and there, kind of like copied words from the prompt. Overall, gibberish. This, like, the structure looks like something that should make sense, but like it's not something you would make sense of. Okay, so, but this is not just about chatbots, and the reason I brought this is because these are sort of like, there are people who think like these systems think like humans, and they are, you know, the things that could save us. I don't know, there's a lot of hype around them. I just wanted to do a quick kind of reality check for the community of speakers that I care about. But this is not just limited for chatbots. If we try search engines, here I query for heart disease, Hamam Libi. This is, you know, one of the top causes of death in Ethiopia and Eritrea. And what you see here is an output linking to YouTube or like a random kind of news article that mentions like heart disease. Contrast that to the kind of rich output you would get if this was, you know, queried in English or maybe in German. So part of that is because knowledge repositories such as Wikipedia, they don't have a lot of this content. So there is no entry for heart disease on the Tigrinya Wikipedia. And social media websites are really full of harmful content. This is a screenshot from Facebook or Meta about somebody posting like a code name. He's using Wayana, which was a code name used to refer to people from Tigray during the peak of the Tigray conflict. This is, you know, one of the deadliest kind of conflicts that happened a couple of years ago, and I come from that area. So you will hear, I don't know, the research director from Meta tell you, for example, 94% of harmful content on Meta is taken down by AI, but that's statistics that doesn't necessarily speak for the kind of languages definitely not for our communities, and these are causing real harm for people. In a way, what I wanted to do here to tease a bit is the current state of technology for Tigrinya, and not just that language, but the community behind that, is that search engines are broken, information is scarce on knowledge bases, and social media is full of harmful content, and chatbots are completely useless. And the question I would pose to you is what kind of piece of technology you use or you find interesting for the kind of community you define across, I don't know, it could be gender, it could be language, other demographic you could take and see and critically observe if these language technologies work. So I'll switch gears and talk about one of the language technologies we built at Lisan AI. This was our first product, a machine translation system for low resource languages. And we presented the work as a demo at NeurIPS in 2021. I will go into the detail because we are at a scientific kind of place, so I thought it's good to. And I had interesting discussions earlier before this, where people are actually exploring what kind of technologies to build for low resource settings. So as we know, in many of these low resource languages, the key bottleneck, one of the key bottlenecks, it's not the only one, is lack of data sets. Equally important, that's not talked about, is compute, but I think for the sake of this discussion, I'll focus on data sets. Here is the pipeline that we used to create this machine translation system. So we kind of rely on online data as much as we could get, news, blogs, social media, and pass them through scraping these websites, parsing, cleaning, and then alignment. But equally important is offline sources, things you wouldn't find online, such as books, hard copies, or magazines from kind of decades. And so they pass through scanning, passing them through optical character recognition system, post-editing these outputs, and then the alignment, the big module there is basically from all of this kind of sources, we have to prepare, let's say, pairs of sentences or expressions between a source and a target language, and just finally the modeling part. In all of this, I would like to emphasize that in our approach, we rely mostly and work with our community members. That's in contrast to maybe later I will highlight how big tech companies, for example, approach this problem. All right, so here I'm showing a screenshot of our optical character recognition system that just takes an image, a page, and translates it into a machine readable text. And in red are some of the problems that it has. So it's not perfect. And so these are the kind of outputs we would then hand out to community members to fix the ones in red, so we can use them for later processing. Right, that's after post editing. The optical character recognition system has two modules. One is a line detection module, and the second one is an LSTM with CTC for the character recognition within a line. And this is a link to the GitHub repository of a very similar kind of architecture project if you want to try to adapt it for a similar for different languages or scripts that you care about. Right. Another important module, so the automatic alignment module. Here, what we are interested in, let's say we have a news article that was published in English and the corresponding article in Tigrinya or in Amharic. And usually what you want is you want to break down each of this into smaller pieces so that you have, if possible, at sentence level alignment or expressions and so on. Yes, you can take the bigger chunks, but if you are able to get even smaller kind of alignments, even better, right? So that's the core task. And the way we approach it is basically, first we generate candidate pairs So think of splitting the source into sentences and the target similarly, and then like you have these pairs that are generated, a pairwise combination, and the task then becomes like a simple classification task, binary classification task. Does this match or not? And the final output would be something like this. And like the double spacing I'm putting is to say like that's the next segment and so on. Our automatic alignment module is based on this work. So we rely on smaller kind of like translation models, base models that were built on like a smaller subset of data set. And so then we compute the cross entropy score according to two inverse machine translation models. So one that's doing English to Tigrinya, for example, and the other that's doing Tigrinya to English. And then over a candidate set, if we look at the weighted average, then over some threshold, you can see some of this will be good candidates, the others are not. All right, and the final one is the machine translation system. Well, this is basically, once you have like all of your pair data, you can feed it through the standard transformer architecture. This is a sequence-to-sequence model that just takes a sequence input, in this case, Amharic, I show, and then output is the English, basically. Now, this is another trick that everybody uses, since there would be like way more monolingual data in a given language than the pair text. You can use a simple trick to kind of make use of that, and that is to say, translate everything you have into a language. Even though it's not perfect, then use it as a source to kind of create an artificial source target pair. That's called the back translation, and you can do this iteratively a couple of times. All right, so evaluation. At the time, we opted for human evaluation on a Likert scale of 5, 0 being completely wrong translation and 4 accurate and fluent translation. And the reason for that was because we created like data sets to do evaluation, and they were very noisy. Like with a couple of segments, the change in blue score was like, it wasn't reliable. And of course, everybody knows human evaluation is anyway more robust and always better. It just is very expensive and not easy to kind of replicate many times. Right. The protocol we used, we reached out to our community. We focused on news, so we recruited experts. They selected news snippets, in this case, like 20 snippets across different genres, across different topics. And then each expert was given the output of different systems shuffled, so they don't know from which system the outputs are coming, and then they did the rating according to the evaluation setup I showed in the previous slide. So the results are good for Lisan across all directions. It's not yet perfect. As I said, 4 would have been perfect. We're not close there yet. But yeah, this was like where at least we could show that like it's possible to build systems that outperform this like mega models, such as like Google Translate or Microsoft Translator. At the time, there was no Google Translate for Tigrinya, and we're updating this work actually as we speak with more languages. That's why we only compared against Microsoft for Tigrinya. And we put out the system, and we wanted to share it to our communities. The sad reality was that at the time Tigray was in conflict, it was cut off from the web, so we couldn't reach the community of speakers. But now things are back to normal, and people are starting to use them, and we're receiving like tremendous feedback on like how to improve them and so on. And we've been working on this like for the past couple of years now. So we're gonna release a much better kind of model in terms of like including more dialects, for example, as first-class kind of citizens, not just one Tigrinya, but different types of Tigrinya, different dialects, and so on. All right. Before going on to evaluation, I guess the main point I wanted to impress on you on this one is that there is just no one way to build like this big, technologies, whether it's translation or, the chatbots. Like, say on chatbots, I mentioned that as a running example. maybe the open AI way is not necessarily the only way. And so that's just kind of like, challenging and forging different alternatives of building these technologies. Cool. So once we did that and we wanted to scale up for more languages, and we needed to kind of like weigh for ourselves, but also for the broader community, like researcher community and other startups and companies, to have a level playing field and compare the results, because we believe like evaluation data sets can fuel that. So we worked on Horn MT. This was a project that was funded by the Lacuna Fund. It had like 5 languages: Afan Oromo, Amharic, Tigrinya, Somali, Afar, and English. So that's 6 languages. This is an interesting area, region, and I want to kind of dedicate a slide to talk about that. One, when I talk about like this, speakers of these languages, we're not talking about like a few thousand people, because that's how it appears when you talk about it. It is massive, hundreds of millions of people behind these languages. All of them, for example, all of these languages are spoken in Ethiopia, where I come from. And so all of these people share the same telecommunication service, banking service, and so on, and yet they live in linguistic bubbles. I don't speak Afar, or somebody doesn't speak the other language, and so on. So that's the reality. So I believe this could have, significant impact, because this is also a region that happens to have recurring kind of conflict. And I believe that language divide does contribute to that. And it's really attractive for doing MT research, because you can talk about cross-lingual or similar languages in the case of Amharic and Tigrinya, and really zero-shot translation in the case of Afar, for example. There are not a lot of resources online or offline. All right, so how do you go about creating this kind of benchmark data set? A brute force solution would look into pairwise, like, okay, let's do Amharic Tigrinya, Amharic Oromo, and so on. That's infeasible. So basically, the way we did it is like we selected a pivot language, in this case English, and then we only just translated from that to each of these local languages. So that kind of reduces the effort into just 5 pairs. But then we have to have like some strict requirements. Otherwise, it would be very difficult, to design this kind of data set that would work for all of these languages. So one, we wanted to make sure we have representative sources, so that it's applicable broadly. And here we're focusing on news, and we know direction is important, right? If you're selecting text just from English, just because the language, it's covering events and areas that are maybe interests of that language, right? So that definitely impacts whether you're selecting source text from Tigrinya and going into English, or English into Tigrinya. So we were mindful about that, and we wanted to make sure that it's easy to build up on. So when choosing, for example, the pivot language, if you want to include Kiswahili or other languages, it was by design that we chose English over Amharic, for example, which would have been easier in this case. So in the methodology, the source selection, we do source selection, sampling, translation, and quality check. So for source selection, we include both local events and global events, so news. And this then at least kind of brings us like you will be able to have local names, for example, in these data sets. And for local events, we use local news websites, and for global events, we rely on Wikipedia current events portal. This is where people cover global events every day. Of course, we only have a certain capacity. So how do we go about like selecting a representative sample across years and different genres and topics? And yeah, I'll go through this a bit quickly. Translation, it's not a very straightforward task, especially when you're dealing with this type of languages. They don't have style guides that are readily available that you can just hand out to translators, or terminology glossaries in Tigrinya and Afar and so on. So you have to create these things on the fly as you go in the project. And finally, quality check. One of the problematic areas for us here, especially for a language that were already included in machine translation systems, was even if you tell translators not to use any machine translation system, because they think, you can't catch them, they will use that. And you have to go back and forth many times. So we had to do some kind of checks. So the manual checks were kind of rating translations. So outputs of the translations of one person are given to another expert to rate. Entity check, a very simple check, but you would be surprised how many faulty translations you could catch. So making sure every entity mentioned on the source is also on the target, and some automatic kind of metrics. Especially this pairwise blue score is how we were catching, like if people were using Google Translate, for example. And of course, basic statistics such as token, word, and sentence length always help. Even if, an expert tells you this is a translation and you don't know the language, at least this can give you some indicators. Right. So we published this work, and it's available, and anyone can use it for evaluation purposes. One of the things we observed after this is actually, so fast forward, that's a year, 2 years after we released the data set and then the systems we talked about. Now I'm going to talk about AI hype. It's a work I'll be presenting. This is from a joint work with Paul Azurne and Timnit Gabru, where we looked at AI hype in natural language processing. So Meta released this machine translation system called the NLLB, No Language Left Behind. It's a single model that translates 200 languages, and they accompanied it with a blog post. And they mentioned this is a breakthrough, a single model. Among them that was quite interesting for us was it includes 55 African languages, the highest quality translations, and they claim they improve the state of the art on all of them, across all 10K directions. So we wanted to check these claims. These are some of the research questions we raised. Is the training data quality good? How good is the evaluation data set quality? And finally, the machine translation model quality. Right. This is still an ongoing work, but we released the preliminary analysis. Here, what we show is for the Amharic and English pairs, the NLLB, what it does is it relies on scraping the web, basically. And if you look at the domains of the sources of text that contribute to English-Amharic pair, here are some of the domains. And I happen to speak this language, so I don't know any of these, domains. What are they? And sure enough, if you look at these things, they're not even websites that originate in Ethiopia or anything that targets this country. What happens is all of these websites have plugins, and these plugins are pointing to Google Translate or other translation models, so they generate automatic Amharic content. So a lot of this Amharic English pairs and NLLB data is actually synthetic data. So it's sort of relying on outputs of machine translation systems. Other things we checked are across cross-language contamination. So sort of tagging Amharic as Tigrinya or Tigrinya as Amharic and so on. So for example, for Amharic, a substantial amount of pairs are tagged as Tigrinya, and many Oromo texts is tagged as English. And for Tigrinya, many of the sentences are tagged as Amharic and so on. All right. And we looked at a subset of their evaluation data set called the Flores data set. I don't have the time to go into the design, but it's sort of similar in a way, the way I explained Horn MT was designed, but the sample was taken from Wikipedia. So a very specific section of Wikipedia, actually. Here, what we're showing is actually some of these pairs have perfect 100% matches. For these pairs, if you take the output of Google Translate. And I have worked with many translators, human translators, and if you give a big chunk of sentence like this one and you ask a translator, I mean, if you ask them even like without showing that answer the next time, it's even impossible to get it right to the dot. So this shows you that like, yeah, it is the output of, Google Translate in evaluation data set. Another thing we looked at is that the coverage of named entities. So they are talking about 50 plus African languages. Yet, if you look at any of like the location, organization, or person mentions, there's nothing that you would find in Tigrinya, for example, or in Amharic. Yet this is the data set that's being used to evaluate like the performance of these models for these languages. So we feel like this is not a good match. Only recently, what we also found is they used HornMT as their training data. So in machine learning, I mean, this is machine learning 101. You do not use the test data as training data, right? I mean, your professor would would not be happy if he finds you stole, the test data and you show like, I have the best score in the class. So partly we have to thank Meta for open sourcing NLLB, because we have a lens to go into POC and find out all of these things, these practices, because what happens is the narrative is open source by definition is like good. Well, it gives you the window, but they also use it to claim many other things. And in this case, what we're showing is this the work doesn't live up the hype. And in fact, at least for us, it had even more consequences, because at the time, we're looking for funders who were very, very interested. Like, we released this system, like, wow, performing Google Translate. How can we do for more African language? And so these things come out and they say, oop, okay, we realized actually they have done it for 50 languages, and you're telling us about like, 3, 4, 5 languages, maybe 10 in a year and so on. So they were like, okay, we're out. So these kind of like claims and so on have like consequences for the for the NLP ecosystem, definitely for the African NLP ecosystem. Right. So where from this preliminary analysis, I just showed like the data set, like at least in NLP, it showed like the top websites contributing to the sources are not even representatives of the native speakers. Inclusions of output of machine translation systems in evaluation data set, evaluation not representative of local context, and very poor model performance. Like most of this I didn't present here, but we showed also for colloquial. And you could see the reservation we had actually at the time. This is a bit anecdotal, but when I looked at the results on our HornMT, this is truth. I was like, they've done a good job actually. Because I didn't know. It takes you months and months and months to find out like what I showed you in the previous slide. I was like genuinely like, wow, okay. Reality check, like let's sit down and find out what's going on. Of course, when you find out that like, they have used that data set, you realize, inclusion of evaluation benchmark data sets as training is not good. This is not just limited for us though, right? Like in the age of like LLMs and so on, this is the main thing. Like people will actively kind of mirror, if not literally lift evaluation data sets to kind of like, to inflate the results they have and to appear like they're solving big problems. Right. So this is my final slide. At least in our context, like in the context of like the African natural language processing and really AI ecosystem, we're coming together through sort of a federation of community-rooted startups and organizations for African language. We're calling it Huniki. And here, what we're trying to do is, okay, instead of like just each of us trying to solve like, in East Africa, there in West Africa, here in South Africa and so on, maybe we can have a unified API and hopefully we can share all of like this best practice on evaluation and so on, and kind of like, provide compelling alternatives to the kind of big tech narrative that exists and dominates like our technology kind of reality today. Right, thank you. That's it.